Morning, guys. So today I'm just going to talk about the upcoming Gremlin query debugging functionality on G.V. So there's a few topics I'm going to cover today. So first of all, I want to give a quick introduction to what I mean by Gremlin query debugging. I'll just discuss a little bit about some of the technical constraints around it. I'll follow on with a demonstration of the actual functionality. I'll give a little bit of an overview of the challenges as I was trying to implement all of this. Once we've got all that out of the way, I'll try and give you a brief overview of the roadmap for debugging and what sort of functionality I've got in mind for it in the future. And then we can just close it all off with a little Q&A for anyone who's got any questions or comments. So Gremlin query debugging, basically, what do I mean by it? So we're looking at the ability to walk through our Gremlin queries as they execute it. And the goal of that is to, first of all, try and better understand the behavior. I know that quite a few people, myself included, sometimes perform our queries without necessarily understanding what they're actually doing. To determine if the outcome of the query is as expected, which is typically when we're running a query, we expect a certain specific outcome from it, but we don't always get to that. And so the goal of the tooling is to try and help identify where that might have gone wrong. To inspect the behavior of the query at a traversal level, I'll just go back to the concept of traversal later, but for just now, we'll just talk about it in terms of the individual handling of each object in the data stream for the query. And finally, trying to provide a functionality that sort of functions almost as a standard code debugger, with the Gremlin query language being very close to code by nature. It just felt quite fitting to have a functionality that would try and mimic the standard code debugging behavior. Now, that's what it is, and I want to just talk really, really quickly about what it's not, because when we talk about query debugging, we normally think of something slightly different. If we go back to other languages such as SQL, where we might be thinking about profiling or trying to find bottlenecks, etc., etc. And this is not what this functionality is. So just very briefly, when it comes to profiling, there's already a step within the Gremlin functionality for this, for explaining the traversal process, which is a concept a bit more unique to Gremlin. There's also a step, so I'm not trying to do something above that or on top of this. And last but not least, the Gremlin query debugging is not a tool that is going to execute debugging at a sort of server code level. We're not providing something that debugs whatever Gremlin implementation's inner code is. We're simply providing a functionality to debug the query itself. So I just want to go over like a few quick small definitions before I jump into my demonstration, just so everyone's kind of got the same language. So I'm going to talk about things such as the root traversal. So when I talk about root traversal, I'm really talking about the set of steps that are not contained within any other step. So in other words, if you think about your query as having multiple depths, where each depth is represented by steps within other steps, the root traversal is all of these steps that are not contained anywhere else. And subsequent to that, we've got the concept of subtraversal, which is the set of steps that are within another step. So for instance, if we look at this little query here, which is quite handy, we can see this set of steps there, nv.id.is is the subtraversal of the where step. And then the where step is the subtraversal of the and step, and being a root traversal step. And now each of these subtraversal has a depth as well, which is the where step is one level deep within the end step, and then nv.id.is, etc., is two levels deep within the traversal because it's contained by where and where is contained by n. So I just wanted to quickly talk about these two because they're kind of important to the way debugging works and to some of the technical constraints around it that I'll discuss after the demonstration. So that's really all I wanted to put beforehand. So what I can do now is I can just go straight to the demonstration. So there's three things I'm going to want to cover during the demonstration. One is to really just show the most basic version of debugging as I started working on it, which is the ability to go step by step on a query. And then two slightly more complex concepts that I've also included in this set of functionality, which is the ability to report on individual traversals or traversers and to simulate their behavior individually as well. So I'm just going to switch over from my demonstration to the software itself. So for the demo itself, I'm actually going to be using Kelvin's air routes dataset, which is one you'll likely be familiar with because it's the one that is covered in the Practical Gremlin book. So this is the one I'm going to be using today. And it's a very simple data set. We have airports within countries and continents, and airports are linked to one another through routes. So our edges are route and contains, and our vertices are airports, version, country, and continent. So I'm going to start with the really basic version of debugging, as I've mentioned, which is the ability to go step by step. So the ability to go step by step is really just that, the ability to run the query one step at a time. So for instance, at this point, I am running the query up to this step. And so you can clearly see the output is going to be, well, in this case, all vertices with an ID lower than 47. If I move on to the next step, we're going to have a little bit more in there. Now we're going to be looking at the edges that are coming out of the vertices that have an ID below 47. There's quite a few, which is why it's taking a minute to load. There we go. So as you can see, we're starting to hit quite a few more records there. We've got 2,500 edges being hit. If I then move on to this step, now this step is interesting because it has several sub-traversals. We have an end step with a couple traversals within it. So we've got a where condition, and we've got this set of steps right here. So in debugging at this point, we're really just running the query up until the end of this full root step. And so you'll see suddenly our results are far more filtered down. But one of the things about debugging is it also allows to try and run inside of these sub-traversals. Now, where things get a little bit complicated here is that this sub-traversal has, rather this end step has a few traversals in it. So when we're running up until this point, what we're really doing is we're ignoring this part of the query. We're pretty much just running up until this point. Similarly, I can continue to step further into my sub-traversals because now we know that our where step has its own sub-traversal. And so if I go one step deeper, you'll see that I'm now going to be running the query up until the NV step, ignoring everything that comes after it. So the step-by-step debugging, despite it being quite a simple thing, still has quite a few unique constraints, being that when we have these complex queries that perform multiple traversal levels, we also have to be able to navigate the steps in a way that makes sense to what we're trying to see. So effectively here, when we're running it this way, what we're doing is we're completely ignoring the rest of the query. So we're really just running it up to this point and closing out all of the sub-traversals in the query. Now, with all that in mind, one of the interesting things in all of this is this isn't regular code. You know, we're not debugging actual code, so we're not necessarily constrained by having to run things in order. And what it actually means is I can pretty much just navigate my query whichever way I want. So, I can just navigate between my steps as I please, and I will get the output as it would be submitted to the server. So unlike, a traditional code debugger where once you've gone past a certain line of your code, it's difficult to go back. With this debugger, you can kind of just navigate in between the steps as you please. And really the main reason for that is that there's no actual constraints on the running of this query. We're really just running slightly different versions of the query every time, which makes it quite convenient. So that's the most basic version of debugging as of yet. So what I'm going to move on to next is the ability to simulate the traversal itself. And this is where things get a little bit more complicated and hopefully interesting as well. So what I've got here is a little traversal simulation tab. Now, what this traversal simulation tab does is it essentially tries to identify for all the elements returned by the query at this point. So in other words, for all vertices with an ID inferior to 47, we want to know if by the end of the query, something is going to be output that suggests the vertex in this case has gone through the query to the end successfully. So in other words, if I look, for instance, at this vertex, vertex 0 version, if we refer back to our data model real quick, we'll see that version doesn't have anything coming in or out of it. And so we can quite easily guess that this traversal is not going to be productive, right? Because at this step, it's going to fail. Now, where things get interesting in this functionality is that we essentially have a way of understanding at an element level what is going through the query and what isn't. So for instance, if you look at our list over there to the left, where we've got a total of 47 vertices, which is the ones that are filtered here, and we can quickly see those that are marked with a green tick are the ones that are going to output something. For instance, if I look at this one, the output of this specific vertex through the query is this path, which contains the initial airport and the edge that leads to an airport that has an ID inferior to 47 and a distance greater than 4,000. Obviously, the query itself is a little bit of a mouthful, but you can clearly see that we're getting the output mapped back to the original record as identified over at this stage. So this is the traversal simulation. Now, traversal simulation runs from the steps that we're selecting. So for instance, if I'm running the traversal simulation at this point, what I will see is the mapping of the vertices returned by this query to their potential outputs by the end of the query. If I move, for instance, to this stage, and it's going to take a little minute because we're going to have quite a few edges in here, what we'll next see is the mapping of individual edges coming out of these vertices to their potential output if there is one. So once again, if I head over to my traversal simulation, now we're going to have quite a few more records here. Because if we look at our query output, we've got a total of 2,500 edges output at this point. And so what we're looking at is all of the edges that are returned at this point and whether they're going to be productive by the end of the query. So if I look at this one, for instance, this is a productive edge, right? If we look at this productive edge and we look at the query, we can sort of understand why. And I'll try and explain it as best I can. So the next step that's going to filter this query is this one, right? So we're going to be looking for edges that have an end vertex that has an ID lower than 47 and a dist property with a value greater than 4,000. So if I quickly look at my edge, I can see that the end vertex has ID 37, which is below 47. So it's going to meet this criteria of the query. And it also has a dist property of value greater than 4,000, which gives us a very clear explanation as to why this specific edge is successful in the query. If I look at this one, we're going to quickly see that this condition is met, but this one is not, right? Because the distance is below 4,000. So this is the sort of overview of the traversal simulation. I can quickly filter my results to just filter out to view the successful traversals only. So we'll see that effectively there's only 3 edges in this query that will eventually output a successful result. But where things get a little bit more interesting is, well, the traversal report, right? So we know that this edge is not going to produce anything in the traversal. In other words, it's not going to get through the query. And let's just say for a minute we want to understand why. Now, obviously, we know why because there's a simple query, and we've just checked that over here. But with the traversal report, what you can do is simulate the query that you've got over in here, specifically on the record at the point you selected, to determine where it fails through the process. So just to show you that in practice, really all it boils down to is I have the ability to run my query step by step against this specific record, which is this edge in this case. And I can use that to find out where things go wrong. So I'm just going to do that real quick. So you'll see immediately the step that fails is this one, which is kind of expected, right? Because we've already determined at this point, this is a problematic step. But if we're interested in finding out exactly where within this set of conditions things are failing, we can actually use this tool as well. So for instance, if I run this, we'll see at this point, for this condition, the traversal is productive. So what that actually tells us is in this AND condition, the first traversal where nv.id.is lower than 47 is productive. If I run the query up to this point, which is values dist, the query is still productive, right? But where I can identify my failure is at this point, right? So this is where the query fails for this specific record. The query is failing at the point where it's trying to determine if the value dist is greater than 4,000, which we already know from looking at the edge and knowing what the query is supposed to do, that's not the case. So the traversal report is a fairly convenient way of finding out where something doesn't happen. And obviously, as I keep running my query, you'll see at this point it will fail simply because at this point, my query is not outputting anything. And so that sort of reveals the core of the debugging functionality, which is we're trying to process the query as a list of steps with an input and an output. So for our query, really, the input is whatever comes out from the previous step, right? So for instance, the input of this step is just going to be those 40 certain vertices. And the output is whatever comes out of the current step. So in this case, it's going to be all the edges that come out of these vertices. And the idea of trying to identify a non-productive traversal is to find those where the output of a given step does not produce anything, which when we think about our queries in terms of finding records and performing certain actions, if a given step for a given record, nothing comes out, we can more or less confidently say this is where the query is failing for this given record. So this is one slightly complex example of this. I've got a couple more queries that we can quickly go through just to show how this all behaves. So again, they're just queries that I've picked directly from Kelvin's book. So I'm going to go with this one. There we go. So we're fetching all of our queries, vertices, apologies, that have a property called type with value airports. So at this point, really what we're looking at is quite a lot of nodes. We're then limiting them and we're projecting them by a few different metrics. So for instance, if I go to my traversal simulation, in this case, pretty much everything is working, right? So what that means is every single vertex that is going through this step is going to output something, which I can easily inspect at an individual level. So you can see, for instance, the output of this first one is going to be this map right here with key A with value ATL, then key B with the region value, and key C with the count of vertices coming out of the vertex. So the traversal simulation is not just helpful for identifying potential failed traversals, but also to try and understand for a given record, how does it come out in the query? What is the mapping between a record or something being traversed at any point of the query up to the end of it? So just a last example, and then I'm going to go back to the presentation, just so I'm not overloading with information. For this last one, we're finding the route between Austin and Las Vegas. So this one is kind of an interesting one, because we're at this point really just filtering to having one airport, only one vertex. And so our traversal simulation is going to be fairly bare. But what it does still allow doing is running the entire query step by step. So for instance, we're seeing that there's 59 airports coming out of this specific one, which I believe is called, let me double check, what's the name of this airport? AUS, Austin, sorry. So there we go. So there's 59 airports that Austin goes out to. And then if we want to filter out the ones that have these codes, we're just going to have exactly that, right? In this case, we're trying to find the airports that are coming out of Austin with any one of these 5 codes, and we can see there's 4 of them coming out. So we already know, running through this query step by step, that one of these is not being identified, right? So IH is in there, DFW is in there, DAL is in there, and we've got a last one, Houston, right? So we can see that this one is not being called. So this is kind of an easy way, or a handy way at least, to understand for a given vertex in this case, if the entire scope of our query, in this case, this filter here saying the code has to be within these values, is being met. So the traversal report is not just for identifying when a traversal fails, but really to understand at a granular level through the query how it behaves at each step for a given record. And it makes it more convenient to better understand how the query runs and what comes out of it. So that's essentially what the Gremlin query debugging functionality is for G.V at the moment. So what I'm going to do is I'm just going to quickly roll back to the presentation and just kind of go over some of the technical bits, or we're going to call it that, and especially the challenges of implementing this functionality, because there's actually been quite a few that I think are worth noting. So where things got a little bit complicated, first of all, is the fact that, well, there's no server level standard for this. So in other words, there's no standard functionality within the Tinkerpop framework that allows for this. And that kind of requires coming up with stuff as opposed to following a sort of framework where we can implement this. One thing I'll add is it seems in general, when it comes to database queries, there's not really much of a precedent for the concept of debugging the behavior of the query. You have quite a lot of tools available in other database technologies to typically profile the query and understand if it's performing well or not. There's not really anything to really walk through the behavior of it, so there's very little in the way of other tools that I could inspire myself from to implement the overall functionality and user experience. Another big challenge in this was the fact that we've got many different server implementations. So G.V is compatible with a whole bunch of Gremlin compatible servers. Gremlin, of course, Janus Graph, Neptune, Azure Cosmos DB, DataStax Enterprise Graph, Arcade DB. Not all of these behave quite the same. The query behavior and the functionality is not equal. And so trying to reconcile all of that together was a little bit challenging. And that requires, in particular, quite a lot of testing. Although that being said, what I've shown up to now is working on all of these server technologies. And I believe from the perspective of then trying to implement further server technologies, like say tomorrow I want to be compatible with some new server technology, the amount of effort involved shouldn't be quite as hard. And this is kind of for one good reason, which is that there's only one tool that I can use to implement this functionality, which is the language. There's nothing that I can use directly from the servers in terms of debugging functionality, but what I do have is a complex language with quite a lot of functionality on it. And so this is how essentially the debugging is being implemented, right? All that we're doing is we're taking a query, we're analyzing some of the records that go through it, and then we're transforming the query on the basis of these records into other queries that allow to then inspect the behavior by just running them against the server. So despite there being no standard for this, there's a language underneath that can be leveraged to generate complex queries around the ones that are being passed through the debugger to create these useful outputs. Another kind of set of challenges, however, is the language is great. It's also complex, and so what it means is the scope of testing for debugging is extremely large. There's an infinite amount of queries really that can be performed, and there's tons of steps, which means when I want to test the behavior of the debugger against a specific query, I won't be able to necessarily cover every single use case or every single permutation or usage of queries. So relying on the language is sort of a strength, but also a bit of a weakness in that there's no amount of effort I can put into testing that will ever cover the entire scope of the language. The handling of subtraversals is quite a challenge as well. So as I've discussed, the way the subtraversals are handled is kind of not a cop out, but sort of a simplified way, which is I'm really just cutting the query up to the step and I'm closing those traversals so I can see what happens. What the Gremlin query debugger is not doing at this stage is inspecting the behavior of the subtraversal itself to see what's going on inside that traversal. And that's actually something that I'm going to be looking at in the future. But for just now, there's not really much in the way of understanding what goes on inside of these subtraversals. It's only ever put in relation back to the root traversal of the query, which means we don't really get to see what happens. Another big challenge that I've got, and I've not really got any solution for at the moment, is how to handle queries that essentially mutate the graph. So in other words, one that will add vertices or edges or modify properties. Because we're relying solely on the language, we're actually running these queries against the server, right? So if I'm debugging a query that is going to add vertices and I step through it multiple times, I'm going to create records multiple times, which from a user's perspective is not ideal. And so what had to be done around this is when a query running through the debugger is detected to have these steps, we simply do not allow the debugging functionality to run. And that's to avoid a situation where, as you debug your query, you end up continuously adding records to your server unintentionally. There's a few options potentially that can be explored that I've thought to leverage transactions potentially on the server technology to perhaps run the query within a transaction and then cancel the transaction so the records don't get recorded. But one of the challenges with that is not all server technologies support transactions. And so if I'm to go ahead with this, it's not going to be there for everything. But that's something that can be kind of looked at later. I think in general, the inspection of queries that add records is probably not the most important. So it's not the end of the world, shall we say. So now that we've kind of talked about these challenges, I just want to really quickly talk about like what's going to happen with all this. So I'm hoping to actually have it released in a couple of weeks, if all goes to plan. So the target release date for what you've seen is the 29th of August. I really just need to write the documentation for all this, which is going to take a little bit of time. Another kind of next step I'd like to look at is this sub-traversal inspection. So the ability to inspect what happens within this sub-traversal. Also trying to find out if there's anything I can do to leverage the explain and profile steps in relation to the debugging outputs. So, we're already capable of breaking down the queries into its individual steps and traversals. Can we use the output of steps like profile and explain and map, what comes out of these steps to the way G.V parses and understands the query? That's something I'd like to investigate. Another thing I'd like to do, actually kind of a silly one, but you'll have noticed perhaps in the user interface that the traverser simulation can display quite a lot of records, but there's no way to actually filter these records at the moment. So I'd like to try and see if I can add some text boxes in here to allow for quicker searches when users want to identify a specific record. And last but not least, I fully expect after this is released that there will be some improvements and bugs identified by users that I'll likely need to take some steps on. And so once this is released, I'll be hoping for some feedback for users to try and understand if something goes wrong, and if it does, why, and how can I improve that behavior. So yeah, that's essentially all there is to the functionality as is. It's coming soon. It's a big functionality. There's a lot of moving parts. So feedback will be really important. Now, just a quick reminder before I close for questions. You can follow my Twitter account to get just the regular previews and news about the product. So for instance, as I was working on the debugging functionality, I've made an effort to post regular screenshots and videos and other animations to try and display a bit more of the behavior of the functionality and sort of the thought process behind it. If you're not already using G.V, it's an open beta. It's free to use, free to download. You can just go and get that at g.v.com, no sign up required. And most importantly, I love feedback. So if something goes wrong or something goes right, I like to hear about it. And there's a couple of ways you can do that. One is to simply email me at feedback@g.v.com, or you can just message me directly right here on the Apache Tinkerpop Discord server. The feedback really helps me improve the solution. It allows me to understand, from a user's perspective, what's doing well and what isn't, and I can then subsequently fix it if necessary. So definitely very useful to have. So yeah, that's essentially it. That's the functionality as a whole.